What's up,
Hello,
everybody? Welcome back. Slowly people piling in. It's a good sign. Guillaume, how's it going?
Hey Ollie, Ehsan, Scott. Hi everyone.
hey.
We've got quite a American stage right now, right? So, Ehsan and Scott, you guys are in Portland, right?
Well, Scott is
Uh,
in Seattle. I'm in Portland, but we're
oh,
basically the exact same time zone, only about three
oh,
hour driving apart.
oh,
Yeah.
nice.
So,
And
but it's
then,
early.
yeah. Thank you guys for doing the early call. Guillaume as well. What time is it for you? Guillaume is in Arizona.
Yeah, we're probably. How I can't remember if there is an hour difference with Washington or not in Oregon, but
There you
Yeah.
it's
Oh, yeah. Because in Arizona, you've got that weird hour that you don't do or do. Or...
yeah. So it switches from the summer to the winter.
Yeah.
go. And we got Faisal. Faisal, how's it going?
Hey guys, how's it going? How's it going?
Good.
Hey.
Every episode you're sounding crisper and crisper. I feel like your bandwidth is evolving as we as we continue.
Awesome.
Cool. Well, thank you guys so much for joining. I think we'll go ahead and get started. Usually we wait a minute or two. I'll just ping a few more people into the room, and then we'll kind of go from there. But yeah, thank you guys so much for joining. Welcome everyone to Archi-Tech number 35. Let's talk Rhino Inside. And we're going to be talking with McNeel developers Scott Davidson and Ehsan Iran-Nejad. So thank you so much for joining. It's super early for these guys because they're on the West Coast. So yeah, really appreciate you guys coming on. We've had a lot of people reaching out about this one, and a lot of people talking about Rhino Inside. So I think we're excited to have you on.
Great. Thanks for
Thanks, man.
having us.
So I'll give you guys a little more of a specific introduction, and we'll jump into a bit about how you guys both got to McNeel and that. So Scott, you're the kind of business development side of McNeel, but you've been at McNeel for like 30 years, which is incredible. And got lots of stories I'm sure you could share about the development of McNeel.
Yeah.
Um, and we'll swing back to kind of how you joined that. And Sam, so you joined McNeel a bit more recently compared to Scott. So you joined about 2.5 years ago, right?
Yeah, if
Uh,
you compare me directly to Scott, it's very
it's
recently.
yeah, yeah,
He's been there
yeah,
for, I don't know, like 25, 30 years or something.
yeah.
Boy, you guys are making me sound like a dinosaur here.
But you're also the creator of PyRevit, which is obviously a huge plugin within the industry in its own right. I also saw on LinkedIn, I was kind of scoping out both your profiles that you worked for Tesla at some point, and I didn't see that before, um,
I did.
which was kind of fun. There's someone that just joined the office here in London that works for Tesla, but it was kind of it wasn't quite as exciting as I thought it was. They were kind of like building the car showrooms and stuff like that. But I was like,
hmm
okay. But
Yeah, it was quite an experience. It was sort of like happened during my transition out of
yeah,
architecture and going more towards technology.
yeah, it's super interesting. So yeah, Scott, I thought maybe it'd be good for you to start off and talk to us about like how you came to end up at McNeil and like I guess summarize like the journey of McNeil since you joined.
Well, I think
Um,
yeah, the I don't know about my history, but I think one of the things that's interesting is tracking, where McNeil came from and where Rhino came
right,
from
there
even.
you go.
And yeah,
Tell us the story of Rhino.
so we actually started uh, as AutoCAD dealers, and I guess we really started as a company that sold accounting software, and this was back in the day when there were mini computers, and and the when AutoCAD came out, um, because we were the only company at that point that was doing computers in the office for accounting for these engineering firms, they started to ask us about, software, like what's this AutoCAD thing, and Bob looked into it and all that stuff, and Bob actually had to go down. There was a garage, right, down in Sausalito there that you go down and you buy AutoCAD and become a dealer, and then you bring it back up here. And so that was how early on we were in with AutoCAD, and so we kind of went along and we're making tools to try to make AutoCAD better. It's part of, selling AutoCAD, but we're also writing some tools. And what happened, and this is where Rhino starts to form, is that there was a NURBS technology group from Boeing that had been spun out of Boeing, and this was back in the early 80s. And this is back in the early 80s, and they wanted to not send technology around. They actually wanted to put it in a product that was popular, and so we were trying to put NURBS into AutoCAD, and AutoCAD, especially at that time, wasn't very good at 3D, so it was really, really difficult. And so we started a Windows framework to developing new features for features that we were going to throw into AutoCAD, and new commands like sweep and to rail and all those things you're familiar with in Rhino. And at one point we figured out that the testers were using the test harness in Windows, and then when we put it into AutoCAD, they didn't care. They just kept using the test harness. And after a while we thought, wow, we should maybe think about the fact that the test harness is becoming what people want to use, and that became Rhino. So it was as much of what we do, it was kind of a happy accident, and that's where Rhino came from. We had lots and lots of testers, and we finally said, how many people would just buy the test harness, and that's where Rhino came from.
Interesting. I didn't know that kind of background story. So you guys were kind of like resellers, then plug-in developers kind of thing, and then you've decided to kind of jump out on your own. And now you've come full circle, and you're invading other people's stuff with the cool plugins. So
well, then there's that. And that's actually an interesting story too. But so now, instead of worrying about Rhino and Revit and Tekla and all these different products, now because of what we did with Rhino 7, we pulled it apart into multiple pieces. So we can integrate inside other products, and now you're looking at the integration of multiple products together, and it's a really interesting theory practice. Not worrying about interoperability, but really looking at true integration between platforms.
So at the time when you were kind of branched off, you talked about a part of it was kind of linked to Boeing. Who was Rhino? Who was the primary kind of user for Rhino? Was it initially for the aerospace industry, or I know the boat builders, for example, gravitate to Rhino as well, and were architects even considered at that point, or
No.
we were just these we were probably still drawing with pens at that point or something.
Well, yeah. So two things. So we're in Seattle, and there's a big marine contingent there, and so and composites were using of composites were getting more and more standard, and so people wanted to know, how do we develop these complex shapes, and then you have to mill them to actually get the right shape, or you have to they're freeform. And the water knows the difference, so you can't just make it an arc or something close. And so so that was one area that we how can you do these shapes? And then another thing that happened was a product designer brought in one of those egg cartons that were molded out of styrofoam.
Oh yeah.
They don't make those anymore, but how do you do this? How do we develop this so that we can create shapes like this? And so it was really marine and product design were the two things. There was a big there were a lot of products being done for Intel, a lot of early on stuff for Target, things like that. Yeah, and so you're right that for instance we were in architecture for AutoCAD, of course, and then we walked away from it to go to marine and things like that. And the first person, the first architect we know that bought it was actually really early on, but it was Frank Gehry on his personal credit card.
No way. That's a
Yeah,
great little. That's a
yeah,
great
yeah,
little tale.
yeah. So he bought it, and we thought, well, that's the whole of the architecture market right there, right? Like you're saying, there weren't a lot of unusual shapes at that time. I mean, there were some, but yeah, I mean, he was so ahead of the time. We thought, well, we're done, and so for years we were, and we still are, into jewelry, into footwear, into product design, and marine, of course, and we kept telling architects quit using Rhino, and eventually we just got pulled into it because we couldn't afford it anymore.
So now, are architects one of your main, users, or are we still a minority, would you say? Or
From the number of seats that we have out there, architecture and the AEC industry as a whole is definitely the largest seat count.
well, there you go.
Yeah. So.
So you said,
No question.
forget Rhino architects, and we just kept coming back.
Oh,
We couldn't leave
no,
it.
no.
And then we brought all these problems of BIM and other software
Big models. Instead of having one object that was really complex in shape that you need to fabricate, you had hundreds of thousands of objects that each object in itself was actually fairly simple, but of course you've got hundreds of thousands of them. So it's actually, since Rhino 5, we've been scrambling to catch up.
That's super interesting.
Yeah.
Yeah, I mean, we do our this project programs feature. We've only done a few, we've done like 16, 17 firms and projects. We asked them what software they use, but it's almost 100. It's 100% rate of using Rhino. The only other thing that comes in is some firms use Rhino and Maya, for example, the Zahas and the Mads and stuff.
Yeah. Yeah.
But yeah, we're at 100% Rhino so far. We haven't found one that doesn't use it.
Wow, that's great.
But I mean, we're only 16 in, but
Quick question: as you have basically lived the birth of Rhino, why the name Rhino?
yeah, great question.
There are so many animals in the Rhino environment now. We want to see. We want to.
Yeah.
Go ahead.
So yeah, the one of the developers late at night. You know how I don't know if you know. There's kind of a custom, I guess, that developers name their prototype software something, whether it's a city or whether it's a whatever. And so late at night, somebody was trying to find a name for their project, and on the wall there was a postcard of I don't know if people know the Durr Rhino, which is it's kind of an old etching of Durr, who never saw a rhino in India but was coming back on a boat, and somebody described a rhino to him, and he etched what he thought that meant, and it's a very bulky looking rhino. Anyway, there's a postcard on his wall, and he thought, oh, I'll call it Rhino. And so we had this test harness. I told you about that test harness where we were using it. It was called Rhino, and we liked Rhino partially because it works in a lot of languages, right? So when it doesn't really have to be translated, and everybody knows what it is. And we got around to actually saying, okay, this is going to be a product, and we had a vote with our test, all the people that were using it, and we had all these names like Solid this and Acu that, and all the standard names that you hear that you'd expect us to name a product like this. And in the end, everybody voted not to change it. All the names we came up with, nobody liked them, and they said just leave it as Rhino 3D. And so essentially it was all the customers vote that left it as Rhino. And in the end, it's been, we thought, it's not going to be professional, and everybody's going to be mad. A lot of people are going to be mad, and in the end, it's been really great because it's so it's so unusual. We can define it as anything. It's not a jewelry plugin. It's not a marine plugin. It's not an engineering plugin per se all the time. It can be its own. I hate to say this, can be its own animal, right? And so
I bet you didn't foresee that you were giving birth to this like myriad of animal-based plugins and all this kind of stuff, which I guess Grasshopper kind of kicked off. But maybe we'll touch on Grasshopper a little bit later.
yeah,
But
yeah. No, we
yeah,
had no idea. We had no.
yeah.
This is just us stumbling, trying to help people. That's
Yeah.
really, yeah.
So actually, one last quick question on as you get started. Was Autodesk at that point in the mix of like, did they own AutoCAD at that point, or was AutoCAD its own thing? I was trying to remember
Yeah,
when.
Autodesk was AutoCAD. So just a quick aside. So there was a whole suite of software that AutoCAD came out with early on, and this is kind of right at the edge of the mini computer PC kind of world, and a whole suite of stuff. And AutoCAD was just one of them, and of course it took off like wildfire, and so they just dropped everything else right off the bat, and kind of really scurried and did AutoCAD, and you could argue that AutoCAD might be the only successful CAD software ever because of the numbers that AutoCAD generated. I don't know, 14 million or some crazy number like that. But yeah, it was actually one of a suite of a Autodesk suite, and AutoCAD was one of the pieces of software. So that's where that came from.
Interesting.
Yeah.
So AutoCAD is the golden standard for like popularity and numbers and users.
Absolutely. I mean, every other software that we all talk about, 750,000, 1 million, 2 million at the most. And, AutoCAD did 14 million or something like that.
Wow.
Unbelievable.
Yeah.
And software specialized a lot now, so you don't see as much cross market stuff as you used to be, and things like that. But yeah, we could talk about that too. If you really want to,
Yeah.
30 years.
There's too many threads to follow. But we will touch on the origins of Grasshopper, but I want to fast forward a little bit and get Ehsan to kind of explain, fast forward a few years, how you got to joining McNeel, and also, at what point did you start to tinker around with, Python and Revit and create PyRevit and how that came about? Yeah, talk us through a little bit about the build up to joining McNeel.
Yeah, so I guess I don't know. It's kind of a weird story. I started playing with computers when I was a kid. At this school that sort of like I was going to, they randomly created this computer class for us. It wasn't really part of the sort of like standard school programs anywhere, but I got lucky to be in a school to sort of like be able to create a very tiny like computer program for us, computer class. And I kind of fell in love with these machines the moment I sat in front of them. And it was back then that we started playing with GW Basic to draw some like very simple graphics and whatnot. And I was totally amazed by the power of this thing. And then sort of like I stayed connected to. I didn't have my own computer until I got to the second year of architecture program at my university. And by that point, I was like a little way too deep into the architecture, so it wasn't really a good time for me to change programs and whatnot. And like back in Iran, you can't even do that because you have to take exams and whatnot to be able to get into university. So it's not really easy to change programs once you get accepted to one. Um, so anyway, I sort of like stayed. I studied architecture in my school, but computer software kind of like and programming stayed with me as a hobby on the side. Um, a lot of the stuff that I would do back then was sort of like playing with C++ and some of those like more complex programming languages after I learned QBasic and GW Basic and those kind of stuff. But after I finished the architecture school, I asked one of my friends, one of my close friends that was an electronic engineer, to teach me how to use microcontrollers. And I started working with him. I taught him C language, and he taught me how to program microcontrollers. And we started working together, sort of like on as a side, as a freelance thing, as a hobby, to create like different devices and whatnot. And I was the one mostly programming the microcontroller side. When I moved to the US, oh, so this is all before I moved to the US. When I moved to the US back in 2010, I had the opportunity. So I didn't have any resume or anything like that for software development to be able to get that kind of a job. The only thing that I had was my education and the resume that I had for architecture. And I told myself like architecture in the US is different from Iran, so let's give it a try and see where this goes. And I sort of like found a job and continued the architecture career here, got licensed and all that kind of stuff. But during that time, again, just as the rest of the story, computer software always stayed with me. So when I was working in Houston, when I moved to the US, I started learning Python at that time because I realized like I'm spending a lot of time at my job just automating stuff and whatnot. And using complex programming languages like C, C++, those kind of stuff is almost impossible. Sort of like being able to debug your application really quickly or write something really quickly, use code that has been created by other people very easily is incredibly important. And I had heard about Python, so I started digging into it and whatnot, and I picked it up really quickly because it's fairly a simple language. And I noticed that like in the, I don't know, in 2, 3 years of me working at that company in Houston, um, this little language contributed to the automation side of what I was doing more than any other programming language that I've ever done. And I attribute it to like how simple it is and how there's so much resources for you to be able to find outside. And sort of like you can, any question that you ask, you can find the answer for it somewhere. And sort of like during this time, obviously, like internet happened and the resources, like everybody has resources to everything. When I was younger, when I was a kid, like we didn't have internet this way. So all of this really helped into getting me good at Python very quickly. And then when I moved to Portland back in 2014, that was the first time that I started using Revit. And it was for a sort of like a large scale project. And I sat in front of Revit with the background of working with AutoCAD and Lisp and Python to do my automation and whatnot. And I was kind of like baffled how limited the software is. Like everything is fairly manual. You have to click on things and buttons and whatnot, and there were no places to run a script to collect data and stuff like that. Dynamo was there, but I looked at it and I knew Grasshopper and Rhino before, and I was like, yeah, I'm not gonna play with this thing. This is not worth spending too much time in it. But obviously, for me, I'm not sort of like judging Dynamo by itself, but just like uh, for me, it didn't really work out. And I kind of like beautiful user interfaces and care and all that kind of stuff. And I were absolutely amazed by Grasshopper when I saw it. So like when you put them side by side, there wasn't really a competition. So anyway, I started digging into how I can get Python to run in Revit, and I found this amazing project called Revit Python Shell, developed by somebody else, and I started using it, and I was like, okay, so now I can stay sane and do some of the stuff that I really need to do. Like, for example, one of the first things that I started using it with was to be able to do area calculations on the buildings. My specialty was senior housing. So it's one of those types of buildings that has fairly limited requirements coming from client, health administrations, like all those kind of stuff. And being able to design while maintaining and sort of like passing all these fitness criteria was really important. So I kind of had to, like, before I started doing Python, everybody was doing this manually, like at the end of every day, just to make sure that all the areas are correct and whatnot. And that was when I started thinking about, okay, so now I have 10 scripts that I have to go to Revit Python shell and run every time. So maybe I can figure out a way to how to add this to Revit UI. And that was the sort of like where PyRevit was born, really towards the end of 2014. It was basically just a folder of Python scripts with a specific name, and it would load those scripts in the UI. It was actually quite sort of like I really liked Pixar's RenderMan product sort of like presentation, and RenderMan has all these different characters, and each one of them is specializes at something. So, like, one of them is really good for shading, the other ones, and each one of them has a name, and there's a graphic with a character, like typical of what Pixar does. So one of the first things that I did with Pirate was that there was a button for every specialty, and every one of them was a monster with a different shape and a different name. So like one was specialized in working with sheets, the other one was specialized in working with another aspect of stuff. So it was like quite fun. And then at some point, I decided to post this on a GitHub repo, which I was sort of like, I just had started to learn how to work with Git repositories and sort of like manage your code a little bit more professionally and all that kind of stuff. So I threw it on a GitHub repo, and the first person, Guy Talarico, was the first person who emailed me about it. And he said, "Oh, hey, this is interesting. Like, can I give you some pointers about like how to actually make this better and whatnot?" And we started talking, and that led me to rewrite PyRevit 3 times in the next couple of years, which resulted into PyRevit 4 that we have right now. So 4 is like the number of times that I've really rewritten PyRevit from scratch. And sort of like slowly became popular throughout the years as I kept adding the tools that I kind of needed for my own work into the tool chain, and improving it as a platform for what I tend to call rapid application prototyping. So if you have an idea of like, hey, I want to create this tool for Revit, Revit will give you an ability to sketch out that idea really quickly without getting into too deep. See if the flow works and the sort of like what you have in idea works and it's possible. You can explore the API, that kind of stuff. And then you can actually distribute it and test it with the users, everybody else. And if they're happy and you're like, okay, I need more performance, then you can rewrite it in a different programming language like C# and make something that's more professionally developed and more performant and stuff like that. And all of this, sort of like all this story led me to an afternoon in Seattle for Build conference. It was a Build hackathon that I met Scott there, because the Rhino Inside had a DLL conflict with PyRevit, and sort of like he reached out to me and said, "Hey, like, can we talk about this? There's like this DLL conflict going on. We can help you with that kind of stuff." So we met there, and that was this sort of like the start of the friendship, and then that kind of led me to start working at McNeel at the end of 2019, about two something years ago. Sorry, that was the long version of the story.
No, that's great. That's why we're here. The long version. Yeah, which goes backs up one of my top tips for young architects, and that is go to conferences, man, because this is where you meet like interesting people that are interested in similar things. So kind of interesting that you guys met at the conference, which makes total sense. But so then you joined. I mean, first of all, we can have a talk about PyRevit for its own podcast, which I know is like a big tool in many offices. Big, we use PyRevit. It's been a really help for what we do. And so then you kind of met and then decided to join the Rhino Inside crew, right? And that's where the story begins 2.5 years ago.
Yeah. So Scott told me that they're working on this Rhino Inside Revit thing, and he told me like we don't really have anybody that knows Revit that deeply, like industry
Mm.
experience, that kind of stuff. And I was kind of lucky to be the first one to be on that, I guess.
No,
I guess
Yeah.
on that path.
it was bad. It was so bad. We had put Rhino inside Revit and Grasshopper in Revit, and we didn't know what we were doing. And and we were sitting across from a large architecture firm, and they looked at me and they said, "So do you have levels?" And I looked at them. I said, "Well, are levels important?" and and at that point, I knew we needed somebody that really knew Revit, and Ehsan, fits the bill and much
Yeah.
more. And so that's been, I mean, it was just it was a great meeting, and I mean, it was great, that we met him at the time we did,
Yeah.
and that's
I
been
mean,
great.
you couldn't have picked a better guy. I mean, like, you may
Thanks,
be the
guys.
first guy that you found, but like, yeah, I think you couldn't have found a better guy for it. So, I mean, I'm super tempted to rewind a little bit and talk about how Grasshopper kind of emerged into Rhino before we delve into Rhino Inside. But
I,
Scott, do you want to
I
add on
could do
about
it.
like,
I could do it really
yeah,
quick, really
yeah,
quick.
go
Try
on,
to do it really
because
quick
yeah,
because it's
we
sort of
can't talk about
interesting.
it without
I
talking
know,
about
I know.
Grasshopper here.
We can talk about history forever, but the grasshopper really was, Rhino.
First question: do you know why it's called Grasshopper? That's no, go on.
Say, I know. Actually, I don't. But other than the legs look like the spaghetti. But
Okay.
and it jumps around from one component to the other. But the early on, we had Rhino script and Rhino, and Rhino script was what architects were using to modify Rhino to do a lot of automation, and that actually became really popular. But we found the problem was that architects, as kind of a whole, they don't know how to code very well, and they definitely don't know how to spell. And so if you have that's a yeah, I mean, but that's they
Myself included.
yeah, exactly, and me too. I'm an architect actually, and so how could we do something where you could script commands, where it was less about syntax, typing syntax, and more graphic, as architects, tend to think a little bit more. And David Rutan, and this is all David Rutan, kind of experimented with a number of things, and came up with what we know as Grasshopper, actually prototyped it in a very short amount of time, and thought it would be just a simple scripting language. You put 5 components together and off we go, and 5 more components, or 5 in the next one, and that was really what it started as. Now it's grown into so much more, and actually is a development language in and of itself, and in a development environment, I guess I should call it. And so it's evolved from there, but it really started as a way to make a scripting language graphic, and a simple one at that. And that's where that started. So,
Yeah, and yeah, I always heard like rumors that it was created like in a weekend or something
it was.
crazy like that.
I think the first interface was actually maybe even written on a flight from Finland to Germany or something like that.
Yeah,
It was actually,
on the way to a conference.
yeah, something like that. Yeah, like we had to show something.
Yeah,
So
let me just create a game-changing plugin on the way.
yeah. And then to David's credit, just over time, the refinement of how it's written and what it is, and the care that he puts into the experience, is something that is just. I mean, we all continue to be just incredible, thankful, and in awe of the level of detail that he can go into in terms of the experience. And so that's something that we should all be thankful for. I think I have to say that, because he's amazing that way.
Awesome. So yeah, then fast forward a few years from that, and how did Rhino decide to, I know you've kind of explained this to me before, but like, how did Rhino decide to jump into the world of Revit? Because Rhino there was like a Rhino BIM at one point, right?
There still is. There's still a
There
number of
still is.
Rhino BIM tools and things like that. But we have this theory or we have this kind of thing that we don't want to do what other people are doing. If there's a decent product, in a certain place, serving a certain set of needs, that's not a place we need to go. We're busy enough trying to do things that other people aren't solving for all of you. And so but what happened was with Rhino 7 was we pulled Rhino 7 apart into its constituent pieces. And with new modern languages, programming languages, you can share parts and pieces of, you can call into one DLL and grab all its functions and grab into a different one. And so we pulled it apart. We rewrote Rhino essentially and pulled it apart into pieces. And we found we could load Rhino as a DLL into other processes and like compute, which is a kind of a web interface into headless Rhino. Hops is another one. There's a number of technologies we thought, well, this would be pretty cool. And just as a way to kind of access Rhino in a lot of different ways. And I think it was Kike or somebody that he's over in Barcelona, thought, well, what happens when we load this inside other, can we access this from other 64-bit applications? And he thought, well, why don't we try it in Revit, right? Just to try it. And lo and behold, it worked. And so one of the big questions we have, and Oliver, you completely, or I know are in on this, is we always would get the request is, how do we deal with our Rhino models and our Revit? How do we get Rhino into Revit? I mean, the simple,
Right. I mean, this has been the challenge for many architecture firms for the last few years, right? We've had the Rhino to Revit interoperability question. We've had the fluxes and the various plugins. I'm trying to think of them off the top of my head. The Grevits, all these different ones. Which
the Excel
yeah, I mean,
through Dynamo. Exactly.
Excel was when everything else failed, you head to Excel and okay, and rebuild it from there. Yeah, and you guys kind of came on, and I mean, I remember when I first again at a conference, I was like, I'd heard of Rhino Inside, and I was like, it was on my list. I was just hadn't got to trying it yet, and I went to a conference, and everyone was chatting about it. So I was like, okay, I really need to check this out. And by the time I downloaded it, I think in the morning, I was already using it on a project in the office by the afternoon, which is which is usually a good sign of a tool. And I think over the last couple, especially when I joined Big, there was, Rhino Inside and then Enscape were two tools that really significantly changed the design process and helped streamline things so we could spend more time, designing and doing those kind of things. So yeah, I remember that for us it was a big game changer.
Yeah, and thanks. And I mean, we were I'm glad it worked. I mean, that's why we do this. That was so that was the first thing to solve is how do we get Rhino geometry into Revit in some sort of useful way that doesn't completely destroy the Revit schema. And again, Ehsan was really key in getting us to understand the different ways that can happen. And so that's where it started, and that was, I guess I'd say, I mean, it's we're still going. It's still learning, still exploring, kind of
Yeah.
where this is gonna go. So
So you started with Revit, and Rhino Inside Revit has, it seems to be the kind of poster boy for Rhino Inside, but it's not just Revit, right? You guys are also have Rhino Inside Unreal, is it? And I think I saw Illustrator and these other things.
well, yeah. So there's a lot of different ways. Some are experiments, and some have gone beyond experiments. So we have Rhino Inside Illustrator, Rhino Inside Unreal. Those are kind of on the level of experiments. We also have Rhino Inside Tekla now, so Tekla's doing that work.
Right.
We're doing Rhino Inside BricsCAD, Rhino Inside Sophistic, Rhino Inside I saw Rhino Inside MicroStation the other day. That's kind of on a level of experiment, and so yeah, trying to get into inside all these. We're not getting inside. It's just a lot of people want to use the Grasshopper interface. A
Yeah.
lot of people want to use the Rhino geometry, the ability to make quick and accurate yet quick geometry calculations to enhance whatever platform they happen to be their mainline platform. Yeah, I mean, I hope that more products do this.
Yeah. So yeah, I mean that's that'll be that's one of the points I'll touch on in a bit is how do you see this kind of the future of BIM and AEC software? But before we do, I think so. You guys came out with Rhino Inside. I think I was trying to find online. It was either late 2019, early 2020. It must have been 2019, right?
It was 19. So
Yeah.
yeah. So
And so it's slowly. I mean, it's evolved an incredible amount just in those last few years. I think what's been really interesting from my side is that even as a specialist, there's still a bit of a are you a BIM guy or are you a computational guy? And for example, in the office, when I first joined Big, I was a title of a BIM specialist, and Guillaume was a computational specialist. And what you saw was like um, the kind of from a designer's perspective, you had the design architects are always kind of interested in Revit, but they're like, I can't really design in there, and it's a completely new thing. And then we saw with Rhino Inside, we were getting the designers or like the computational designers getting, brought over into the Revit world because now there's this familiar toy and interface that they can use to create stuff. And then you got the more, let's say technical architects or the architects that spend more time in Revit come over into the Rhino Grasshopper space because they were interested in Grasshopper and that kind of thing, and now they can use it, uh, in the production of drawings and in the documentation space. So it kind of became this like gateway between the two worlds, which was really interesting to see.
yeah. Well, when we could travel and actually visit with the people
Yeah,
before the pandemic, one of the things we used to see is, and this was just a real physical change, was that we used to go to firms and they'd have their Rhino meeting in one room and they'd have their Revit meeting in another, and they, the interface between those two was, maybe one person. And so we always, as we started talking about Rhino Inside Revit, we actually started to see meetings where there were, half the room was Revit and half the room was Rhino, and actually talking about the same workflow, which was really great. Now, unfortunately, I still couldn't get them to sit actually on the same side of the table. It was still Rhino on one side of the table and Revit on the other, but that's a whole different issue. So maybe that's a post-COVID thing. Everybody's next to each other.
I mean, I felt it was like a perfect plugin for me because I'd just come from front where I was like, in the BIM world, but with Rhino and Grasshopper and using Everfront and I guess bringing the basic components of BIM into the Rhino world. And so when I joined Big and I was kind of more jumping back and forth between the platforms, it really came to light. I also see we got old Andrew in the crowd, and he was also the creator of Human that also does the same kind of bring some of those BIM components into the Rhino space. So I felt, that I always found it strange that there was this split between, BIM and computation. I always was like, it's like two sides of the same coin, obviously. And for sure, Rhino Inside was a big reason for that, breaking those kind of divide a little bit between down.
Well, I think something about BIM that needs to be looked at, and I know Andrew could jump in on this call too because he knows all about this. But the one of the things we're seeing is that having file format I think files are actually the problem. Like for instance, having to have everything in one file. And like you were saying, at front, for instance, you were doing BIM like things, but you'd probably start with the Revit model and then break it all down and break it all out into Rhino information and Excel spreadsheets and whatever else you needed to break that part of the information down for that part of the fabrication, which is a ton of information just in and of itself. And I think that's where you're seeing Rhino used a lot, and this whole Rhino Inside and Revit and this whole combination is now you have a lot more granular control to break the project down into the areas that you're working on, and we see that up front where when you're working on massing and site plans and the larger pieces, maybe a lot of it's in Rhino, and then as it kind of moves down the process a bit, now maybe shell and core and floors are in Revit, but the facade's they're still working on the facade, which might still be in Rhino. And now with Rhino Inside Revit, there's just a lot more granular ability to work on different parts of the project in an integrated environment, right? Like in a smooth transition and being able to for instance, put the facade into Revit really fast when you need to get drawings, but still work on it in Rhino and Grasshopper if you need. And then, as it transitions more and more in production, it would be in Revit. But I think part of this is how do we break apart this gigantic, unwieldy sometimes amount of data to fit the workflow of the person doing the work on the desktop. And so that's a big. I mean, there's a million ways to look at that. That's one of the ways that we see that we found that it's been really helpful that way.
So Rhino Inside is obviously kind of like you guys are, I guess, putting a band-aid and fixing a systemic problem that we have in that we have these two different platforms, Rhino and Revit, and each one is great for what it's good for. But what do you see as the that's on the horizon of around the corner? Like Revit, for example. I'm not bashing Revit, for example, but it's great at some things, but it's also it's slow to develop. It's an expensive piece of software. It's maybe not delivering the full potential of BIM, let's say. At the same time, you see all this tech coming in from the game engine world, and Unreal getting more and more popular with architects. Do you see like a new BIM platform on the horizon, or are you guys even tempted to kind of jump in? I know you're kind of more focused on the Rhino Inside stuff, but what do you see as the next generation of BIM from your perspective, Ehsan and Scott?
Does Ehsan want to take this?
Oh, that's a hard question to answer.
or like, do I guess maybe I could simplify. Do you see the future as being like a single platform that's based on some game engine where it's BIM and maybe also visualization kind of wrapped into the same thing, or do you see it as the kind of what you're doing with Rhino Inside as a way to communicate between all these separate things, like rather than one platform that's great at that's sort of okay at everything? Is it better to have these kind of separate programs and work out a way to communicate between them?
So I guess I want to answer this question in my kind of own way, and the way I'm seeing the market.
Go for it.
I have a hunch that, well, this is something that we all can see in the industry. I don't know, 30, 40 years ago when Autodesk started developing these different applications, or these companies started creating applications, making an application like Rhino was not an easy task, or something like Revit was not an easy task. It's generally reserved for people that have a lot of experience in software development. They can understand all the challenges and whatnot. During these past, I don't know, whatever number of years, software development has become a lot more accessible. One of the most important things that happened was that we ended up having languages that have runtime and they are simpler to work with, like Python. You don't need to compile your Python application, you just write it and run it. And because it has a runtime, it means that you can put the runtime in different applications, and you can use Python as a scripting language for another software that you have created, like Blender. So that sort of like made software development much more accessible to the actual end users. Just the fact that they can access it very easily and they can learn it very easily. It's not as hard as it was before. So I always joke with my friends that, like, if you grew up learning how to use a calculator in this day and age, you kind of need to know what Python is. Um, it kind of does the same thing for you. So you can see that there's a lot of architects, there's a lot of people in different specialty fields and whatnot that can actually program now. There's a massive amount of code generated by many people across different industries that's shared. So if there's something that you want to do, there's a very good chance that somebody else has already done a good portion of it, or you can sort of like combine a couple of different modules and plugins and get your job done. All of this, I think, has resulted in sort of like an ecosystem that the single ubiquitous software developer, like the vendor like Autodesk, is not in charge anymore. Because they in charge of the logic, right? The logic of their applications, because they create these platforms and then everybody starts developing on it. And those people that develop are not necessarily software vendors anymore. They are architects and like every end users that are actually creating products and whatnot. So I'm very curious to see how this creates a shift in the way that the industry, the software development industry, actually develops software. So like I had a sort of like a crazy idea a while ago that I was talking to Scott about, and it was, hey, maybe like we would see something like a user interface platform that would show up in the market that has nothing to do with logic, but it allows applications like Rhino and AutoCAD and all that kind of stuff to put their logic in that application as a plugin. And that would mean that for the industry user, you would have a universal user interface for all of that, right? And this is sort of like a simple idea based on the fact that maybe we can decouple UI from logic in the industry and tell Autodesk and everybody else, hey, you still charge for your logic that you have created. Just let us keep control of the UI, so we have a universal environment that we can work in. That might be some of that, and you can see sort of like variations of these ideas show up in different places. Rhino Inside is kind of a sort of like a play, maybe a play on this idea, because it kind of uses Revit's user interface as the ubiquitous user interface in the industry and brings the Rhino logic into it, so you don't have to work in two different interfaces, I guess.
That's
I don't
super
know. There's
interesting.
just
Like the architect's workshop essentially, and then you just load in
yeah.
what you need.
Yeah, I can riff on that too. I completely agree with that. And the part that is interesting too is that modern day development languages have freed developers up from a lot of the barriers that used to force us into application. So, when we were in C++ and C, and we had to deal with memory stacks, and it was nearly impossible to share information between two processes. It kind of forced you to be into one process, and that process had a really difficult time talking to another process. The only way to really do it effectively was to go through a file. It was either a temporary file or real file format, and that was all you had. And these days, with more modern languages, you don't have to deal so much with memory management. There's automatic memory management and cleanup and all those things. And so that's one thing. And the other thing is that most of the programming interfaces are self-documenting. You can go into a DLL and find out, and it will, give you its public methods, for instance, and you can exchange data formats in some sort of sane way, and that makes programming so much more accessible to people that aren't, computer scientists from birth, essentially, and it's not this black art anymore. It's very, it's much more accessible, and that's part of what you're seeing too, is just this ability to. I mean, the reason Rhino Inside Revit can work is because of the whole .NET and its ability to publish things publicly to other processes.
And I think it's easy in apostrophes. Like from your point of view, I think there is still like very few architects that are able to even code, like let alone complex languages like C++, but even Python is kind of a mystery for them. I'm just wondering, like, given kind of how you see the environment develop with like more the end user being able to chime in, like would you suggest that architect or the architecture education integrates coding in their program, or do you think that's something that's kind of more reserved to very passionate people?
I think you've already seen. I think there's already been a number of programs that have done that. And I think, I think every university should be teaching some level of development. I mean, teaching Python, like Ehsan said, is a great stepping stone into it, and really good place to start. And it doesn't probably have to be much more than that, but a lot of them teach Grasshopper and things like that. You can see this. You actually see this in other industries too. Electrical engineering is a good example, where when you go through electrical engineering education, it's not about resistors and analog circuits as much anymore. Every electrical engineer anymore comes out as a software developer, because it's embedded systems. It's a digital world. The behaviors are programmed. They aren't, due to the physical aspects of an analog system. You could argue that architecture, is now completely digital in terms of the practice of architecture, in terms of the tools that you use, and getting control of those tools, and being able to write the tools that, from the point of view of an architect that knows how architects work, of course. I completely agree that some level of development has to be part of your education now.
Yeah, and I guess you're preaching to the choir here, but like my first exposure to coding was through engineering studies that were totally separated from the architecture studies. But it seemed like every engineer, whatever they're gonna end up being, and there were so many different type of engineers out there, they had kind of an exposure to what coding means, and just get into their head the thought process of like just developing an algorithm. And I think now that, going back to architecture, you can kind of see that architects, or some architects at least, in the way they think even about their project, have this kind of method. And it's not that far from writing a script or developing code. It seems like, things are very compatible. So I'm very hopeful that more and more university will kind of include more basic coding. And I see there is Evan in the crowd as well, who is working with me now. I'm not working at Big anymore. I'm in Arizona in the design build office, and we're trying to develop this class for Arizona State University and get Grasshopper and Rhino in the curriculum. So would love, we'll make sure to get that in the students' hands.
Yeah, thank you. I mean, you call us anytime. We'll help you out. But the thing that this is a architecture, the construction industry is a big industry, and this is not a quick move. This is a generational move, and and we're starting to see it. Where people that, for instance, learned RhinoScript, people that learned Grasshopper early on, are now getting into management positions. So the decision making is starting to shift too. I mean, that's how long this stuff takes. It's not just a couple of years here and there. This to move an industry is it takes a generation at least, where people have to be familiar with the tools, they have to be comfortable with the tools, and then the business practices will change to use those tools, if of course if they have an advantage. And so you're starting to see that the industry change. It just is a lot slower than I think some people would like.
Yeah, I think that's something I've definitely noticed is like, it's still, like I said, it's we're only just getting to the point where people starting their own practices, or they're starting to get to like the more senior levels of firms. Those Grasshopper users actually get to that point where they can, create it and add it into a firm. So I know we've had you guys for about an hour. I thought I'd open it up to see if anyone has any questions, if you got any more time. And then we have one from Invit. Not sure if I pronounced
It's
your name correctly.
Can you hear me?
Yeah.
Yeah. Hi, I'm Avneet.
Hey.
Yeah, so the name is Avneet, and I had a question on the same topic that we were discussing, teaching coding skills or Grasshopper skills, let's say algorithmic skills to architects. And I had this conversation back when I was in university. I was studying in Delft 3 years back uh, with a lot of architects, and according to them, they feel like when they're designing things, it somehow kills their creativity. And they think that designing through these algorithmic process somehow hinders the process to think outside a particular box. And I don't know what other people in this crowd thinks about. And another thing is when you're writing code, you somehow have a goal in mind, and then you're scripting. I'm still an amateur when it comes to scripting in Python and all. But for me, it's always there is an end goal, and then I'm scripting. If I'm making a Grasshopper script, and if I don't have an end goal, I somehow get lost. Uh, and when you're designing, you somehow don't have the end goal. It's the procedure that you are going through to, come at the end goal. If you involve scripting while designing for normal architects, I believe it would totally break down the way architects or creative designers or anyone in the creativity industry thinks. Mm. Do you have
Okay.
any comments on that?
I can.
I
Well, Scott,
Go
do
ahead.
you want to
go
jump
ahead,
in
Alan.
on this one?
I can
Ehsan?
start. I'll start this, and then the thing. I mean, there's so many ways to look at this. All the existing tools still exist for architects. There's nothing. None of this is being taken away. But one of the things I would say is that there's kind of a traditionally I see architects, and this is just right in front, is when a client comes with a problem, a traditional architect might come up with three solutions. Here's the problem. Here's my three designs. Let's talk about any one of those three, and then it kind of gets refined from there. But you just went from problem to solution, or to three solutions. And I would say one of the things that affords us now, and this is one of the ways of changing the thinking a little bit, is what would happen if we went from, okay, that's the problem that's been given by the client. And now what I'm going to do is develop an environment or develop a algorithm that looks at the solution space, that looks at, isn't actually a target at one solution, but it's actually a space of, if it fits these criteria, it's valid to solve the problem. And now I can kind of jump around within that space to find solutions and refine them. And hopefully maybe get more data about each solution before I put them forward as a solution. And so to me, that's one of the ways to think about it is don't try to program a solution, but actually how do you program an algorithm that is looking at a space, a 2D or 3D space of solutions.
Yeah, that's a great way to see it. Like the way I see it in addition to that is that if need, like the beauty about being able to script or to create algorithm is that you can think outside the box because you're the one creating the box, or the script is you at the end of the day. It's not really like you're basically manipulating geometry, and at the end of the day, I think every architect, draw with lines, with volumes. You can break it down to very simple elements, but whether you draw it with your hands or you are assisted with a tool at certain points, it doesn't even have to be the whole way. Like, I don't think there is many architect that would just scrap any kind of hand drawing and anything and just design straight into Grasshopper. But at the end of the day, you're again manipulating geometry, which is what architecture is, until it becomes real, I guess.
Yeah, I jumped in because I wanted actually to touch on this question, which is one that's near and dear to my heart too. This sort of like relationship between the space of creative possibilities and software and the tools that we use. And I think, I agree with everything that's been said so far, but there's both, as Scott was saying, there's the ability to sort of embed additional intelligence and let the computer do some of the searching for you. And then I think, as Guillaume was suggesting, you're also in a position of kind of crafting your own tools, making your own paintbrush, embedding sort of your own thoughts, or making for yourself a creative medium within which to explore. And that medium can contain the constraints that you care about, or it can just be a way to like spur creative inspiration. You can introduce randomness, or you can introduce whatever sort of resistance you need. And I think that's true of all tools, computational or not. The tools that you choose to use are going to impose a particular ontology, a particular perspective, a particular set of things you're allowed to think about and work with. And being able to code gives you the freedom to kind of describe that space, decide what that space is. How much do you want intelligence feeding back to you? How much do you want to be resisted on particular things? And how much do you want to have your possibilities expanded by virtue of some piece of automation?
And you could, and to continue to talk about that is that I mean, if you look at Gary, for instance, and you look at a lot of well-known creative architects, is that they explored different mediums to design with. So Gary had a specific kind of paper that they would use to model with, and they digitize it at some point in time, but that new medium, that different tool that they used that broke beyond a 2D pencil and whatever else they used, but that medium allowed them to go to new places and do new things and different things. And so this has been happening forever. It just happens that now we talk about it being on the computer and not developing new tools and new mediums essentially on the computer than doing it in the physical world.
Thank you for your answers, everyone. I think I really appreciate getting this kind of feedback from people working in different industry. but I still think that architects don't think in this way. Maybe like 2 or 3 famous architects out there are trying to explore and break the boundaries and creating or setting a, let's say, an example out there. Um, mm, but most of the designers that are coming out of university right now still are not thinking in that way. So I studied back in India, did my bachelor's over there, and then I went to do my master's in Delft University, and I'm right now in London. London is known for a lot of computational designers, yes, because of AA and other DLR programs, and that's why a lot of computational designers are over here. But in rest part of the world, it's still like people prefer using uh, the same mediums that were being used, and talking to them still feel like they are not really happy with the way things are going. They would rather hire computational designers and tell them what to do rather than, trying to learn and code themselves.
So I would say
I think
that's sort of an individual's choice, right? The way I'm looking at it, if you're a painter, you have a set of brushes available to you, and let's just abstract this and simplify it, and just say, hey, you in your career you work with these 2 different brushes, and then now there's 3 more available to you. As we have seen it in the sort of AEC industry, the pen and paper is still used. If I want to start a new project, I'll definitely start with a pen and paper because that's where I feel most of my freedom is. But as you go throughout the design process, you hit different challenges. You have different ideas. You want to be able to explore those ideas a little bit better. These tools actually sort of like help you in that process. So as your design process becomes, I guess, more complicated, I don't want to say complicated, more specific towards the actual thing that you're designing, you might be in need of other tools to perform those tasks. It's up to you if you want to hire somebody else to do it for you, or you want to go learn and do it. And obviously, like some of these tools are pretty complex, you're not going to learn them on the job. So if you are that type of a person that wants to be ready for these challenges and learn new tools, you're generally the person that spends their afternoons after work and whatnot exploring new tools to see what new possibilities are. And if you're not that type of person, you're spending your time doing something else. So I think those are really individual choices, really. The good thing about, as Andrew mentioned, the good thing about sort of like the way the programming landscape is changing is that those tools that have been developed for you by other people now have the capability to be customized very heavily by you into something that works for you and your design a little bit better.
Yeah, and I think don't underestimate too what's expected now from the design process. So a highly refined design process based on this, you can grab and get so much more accurate information, or more accurate information. I call it design time analysis, about the design and about its performance and about its ability to, if it's leased, information about how much leasable square footage there is about the job, far earlier than you could, and faster, for projects. How much more do people want to see CFD? How much more do people want to know the thermal performance? How much more do people want to know the impact on views or on pedestrian paths, almost real time during the design process? So you can go through a lot more and have a lot more accurate information without, in a lot quicker way. And so one of the things to maybe look at too is, are the owners and the people paying the money for these jobs, are their expectations changing about the information that they can get and the information they need during the design process, and that demands these new tools also.
May I add something to this explanation bit, because that's why actually I joined the platform here. First of all, thank you all for this room. It's a great room, and it's really I'm a big fan of all the names here. And thank you for all the good work. It has been made our life easier for a reason. But just commenting on the idea that how people are receiving the work of computational architecture, and generally, I think there is a big like an unseen place for those expectations and the promises some of the computational architects are actually giving. So not everyone knows the actual limitation of the tools that they are using, and not all those who actually use it actually promote it in a realistic way. Some people actually just overpromise to get a job, or overpromise to get some sort of a fame, or this kind of reputation, but then when it comes to the reality of it, there's plenty of challenges, disappointments, and stuff like that, and that's not that shared in the field or out of the field. So it gives that I don't know, this kind of gloomy bit that yeah, they are not that real when it comes to the actual work, because not everyone that says whatever they're saying, they're actually doing stuff. Plenty of users in the field, and most of that don't know actually the actual limitation of each tool, that it will crash at some point and it won't give as much promises as you say it, and it might need some time to prepare a data set of whatever building you're testing or stuff like that. So these kind of promises needs to be a little bit more realistic for the outer circle of the field, so it can be actually people. It's not just a magic one that people, yeah, I will give it to the computational people and they will actually solve it in 2 days or whatever, but it cannot be done that way all the time. It's just sometimes it will need more effort, and it will have some challenges to be done in the right manner. And most of those who actually use these tools don't know, or they don't put these prices or these challenges into spectrum properly when they pitch the work. That's on one side. And then when these failures creates more resistance to those who actually in need for such a tool or for such an approach. So I think this dilemma of expectation and promises is something needs to be revised in the practice and also in academia. For myself as an academic, I think it's important to highlight this to students, that this is a limit. Whatever the tool you're using, it's a tool. It's not something that will replace you. And this is a question I have on all my lectures mostly. Would you think that architects will vanish at some point? Usually I say no, but the idea that this is somehow perceived by those who listen to us is something that we need to revise and revisit, to see I think promote how limited, where is the limitation. Actually, it's not limited, but I mean, where's the limitation could be, and how much, what is the cost of time or computational resources that we need to achieve whatever these videos would tell you, or whatever clips that you have seen over the internet that says that there's a building that twists all over the place, and these kind of stuff. It's not that easy to be done all the time. Sometimes it needs more effort than you can expect, and I think that's not that promoted in general.
Just to comment on that, because I think that's very real. I think the sort of like relationship between the profession and computation has followed a kind of a classic Gartner hype cycle of, and it's hit different parts of the industry at different times. So I think, maybe the kind of real innovators were further along this hype cycle earlier, maybe even 10 years ago. But there's definitely this pattern of a kind of peak of inflated expectations followed by a trough of disillusionment. And I think we're coming to a point now where we can start approaching a slope of enlightenment and a plateau of productivity. I think some firms have been productively using computation for a really long time and are not thinking of it as a sort of like a replacement for, for architects or for creativity or for any of this stuff. But I think that, depending on where you are geographically, where you are kind of in the spectrum of the industry, there are going to be different positions along this scope, both from the capability of the capabilities of the folks at the firm, or the folks who are making certain promises of what they're capable of, as well as the kind of sets of expectations that are imposed on that from outside. And I think this also operates differentially across different parts of sort of what we're talking about when we're talking about computation. So I see the like ML stuff, all of we're hugely up on this inflated expectation, sort of really unrealistic understanding of what machine learning can bring to design computation. I think it's incredibly promising, but first we have to get over this kind of, oh, it can do anything, before we'll move to a point where we can take advantage of it productively. So I think, as far as talking to students or practitioners about this, I think it's just a matter of being realistic at looking at examples where this stuff has really paid off, in some of the firms that were sort of early to it, but also, not overestimating what it's capable of. It's not like this takes a human out of the loop, nor should it, in my opinion.
I think, we'll see. To go back and answer your original question, I think you'll see, sometimes we'll be waiting for the firm that you work for or whoever it is to adopt these things, and we've had this barrier of crazy parametric geometry, which I think is kind of we're still having issues that you use these tools and for some reason your design's just going to look absolutely bonkers. But I think, like Scott mentioned, we are starting to see a shift when we're getting these Grasshopper users actually come into starting their own practices or more senior management, and they kind of know the benefits from a user's perspective. It just takes a little longer to get that than we might think. But anyway, I know we've had a few more hands raised. Scott and Ehsan, I don't know if you've got a bit more time. I think we've got Lemma and Evan,
Yeah, sure
which we'll
thing.
go through. But,
Great.
sure.
Hi, Ollie,
Okay.
and yeah, thanks for the room, guys. It's been really insightful. So for me, from my perspective, so I am an architect, but I actually do computational urban planning. So I tried over the years to grasp a lot of the tools that I needed to do a lot of master planning work. And I think one of the things that has always sort of bothered me or frustrated me a lot was just, as Anas was saying, I mean, it does take really a long time, and it's not as easy as a click of a finger when a client says, we want to have this all, with AI and ML and optioneering and all this kind of stuff. And it's really, really time consuming. And I was just wondering if maybe it would be a better approach, or I haven't seen one, which is maybe why we're starting to do that in my team. But looking into sort of the sustainability and environmental kind of approach that the clients are always asking for. So, clients will usually say, we want to have our building be LEED certified, or we want to have our buildings or our district to be a positive energy district. And it's more like, well, what exactly does that mean? And I know that we can put in our own, our own, uh, you know, uh, algorithms into there and our own kind of parameters. But to do that for like newly for every single project, it just takes so much time. And I was wondering, right now we know that SpaceMaker has been bought by Autodesk, and they're starting to do a bit more district level. And I think my frustration is more linking GIS tools of planning together with the built environment. And I'm not really seeing that there yet. And I was wondering if that's something, at least in McNeel or with Rhino and Grasshopper, that you guys are looking into.
Well, there's a lot of development going on, not from us directly, that in this area. If you look at somebody like KPF's urban planning group, and they've shown a lot of what they do publicly, where they're using Rhino and Grasshopper to do a lot of that kind of calculation on that level, and I highly recommend you search on them
Okay.
and see the kind of work they're doing. There's also a new plugin that just came out where it's City Engine inside, or it's Rhino Inside City Engine. Actually, there's now a new plugin for that, and so ESRI is starting to get in on the game here of again sharing these tools. It's really about sharing the data and the tools, and what everybody does with it is all part of this. But I would look at Grasshopper. I would look at the plugins for Grasshopper. There's a number of them to take the urban planning data adjust it with other data, and that's what Grasshopper is good at, and then run it through some type of analysis. And those tools are all moving forward, and they're much further now than they were 3 years ago. But it's we just are happy it continues to move forward. But I would definitely look at KPF's work. And
Okay, I'll check that out. Yeah.
They've been, and they have a number of presentations that are really good, and so that's where I would go.
All right. Thanks, Scott. Thank you.
Also, check out Hyper. They have like a bit of
Yeah, I've checked
what we're
Hyper.
talking about.
Yeah, I know them quite a bit.
But yeah, since Andrew's here, we'll have to give them a shout
Oh,
out.
hi, Andrew. Thanks. I've looked into it, and I've done a few demos, trials on
Awesome.
there.
If you'd ever like to talk further or let us know what sorts of GIS capabilities you'd like, yeah, hit me up.
Yeah, sure. Yeah, that'd be cool. Awesome. I'll hit you up. Thank you.
I also have been getting a lot of GIS requests in the office, and I hate GIS now. But so yeah, any
Me
better
too.
ways to do
I
GIS,
mean,
I'm all ears.
it is because I mean, at least for me, it's every time I'm trying to combine GIS with the Grasshopper and Rhino, and it's like sometimes I feel like I'm back to the beginning of SketchUp days, where it's like nothing really is fitting so flush, and it's just a nightmare kind of because you have so many layers upon layers upon layers, and it's sort of you're not having it work how or as smoothly as you'd want it to work, and it's just because there's just so much data that you're working with, and yeah, but the clients just sort of want everything packaged into one, and it's really sort of knowing what exactly is everything. And I think, Scott, you mentioned before, whether it's CFD analysis, optioneering, machine learning, and so on, and it gets a lot, and I guess it's basically up to us as the architects and designers to kind of put a cap of what exactly is important, how much data is important for us to actually show, and what is necessary. Yeah.
Yeah, and we want to help with that. We'd love to be part of that conversation. We'd love to listen to what's been going on, and if there's any way we can, smooth it out for you, that's what we try to do. And so it is an area that we're well interested in, um, you know, making it easier, and whatever that means. We can talk about it, but ongoing conversations about this we'd welcome.
Cool.
Great. Thank you.
I see we got Evan. Maybe if you want to
Yep.
hit us with
Yep.
the last question. Sorry, you got stuck between me bringing you up onto the stage. You got lost in like the never zone
That's
for
right.
someone.
So
But you're here
my
now.
background's mostly in digital fabrication and like robotics. So I'm finding an interesting dialogue going on here about the apprehension of architects, and I've actually found that by approaching it from the lens of fabrication, it's a little easier for the architecture community to digest. Um, as I sort of move through my career, I've used Rhino and Grasshopper for like robotics programming, and then as well as streamlining workflow stuff. And one really, really important thing to that was the development of robots in architecture, being able to program robots right inside of Grasshopper. And I think that speaks a lot to what we were talking about earlier, which is like a non-agnostic program, which allows you to sort of layer multiple things on top of itself and have like a free platform. Not to get too long-winded, but my question, and because my day-to-day is mostly in fabrication and shop drawings, I was sort of curious if there's any movement at McNeel to try to implement more, not necessarily SolidWorks style stuff, but more something for shop drawings, and how that like transitions as Rhino's being developed moving forward.
I don't know how much I can say about this, but because obviously, I mean, if you look at Rhino 8, which is just early in its infancy right now, you can see some of the stuff we're working on. The answer to drawings is yes, we're trying to get better at it because we terrible at it. And so we continue to try to push there. In terms of parametrics, let's call it, it's not we continue to experiment in that area. You can think about Rhino Gold as jewelry parametrics, and you can look at Visual Arc as doors, walls, and windows parametrics, and you can look at Grasshopper as freeform parametrics. A lot of stadiums and things like that. Where it's just the parametrics are out of this world in terms of the complexity. And Grasshopper has handled that. We are experimenting a bit with how to add more intelligence and more intent in the geometry. And the reason I'm being so vague about that is I don't know where it's going to lead us. And you'll probably be able to see some at some point in time. But yeah, we are from a fabricate. I guess one of the things I'd like to do to say is the whole fabrication thing. Let's call it LOD 400, 450, and beyond. That's a big area that's underserved in the industry, in the construction industry. And Rhino, like you're saying, Rhino Grasshopper has been a tool that's been used there a lot, and to us it's very important. It's an area that we see a lot of opportunity. Most of the innovation we see there is actually innovation of fabrication techniques with certain areas of a building or certain materials, and that's where Rhino and Grasshopper a lot of times can really help. Is that it's not that the digital tools, like the actual software tools, are available. It's more that the digital process is available, and therefore we can accelerate that. Mass timber is a great example of that. There's a lot of different digital. So digital fabrication techniques, the ability to then get the right geometry, accurate geometry to drive, that's hugely important to us. The 2D drawing part, we'll try to keep up there, but so much of the digital process is, bypassing drawings, using the 3D model directly, and things like that. That's an area that we think is underserved, and it's an area that is very important to us.
Great, it's great to hear. And I mean, right now it's pretty obvious that a lot of people are using it for that, and I'm interested to see where it goes. So thanks.
Are we, and this is true for everybody in this call and everybody you ever meet. Is the only way we know what to do is when all of you talk to us and all of you complain about what you do and don't have, and all of you tell us what you're trying to do. That's how we're driven. That's the only way. We don't really have plans as such, and we just try to help. So as much interaction, as much as you can talk to us, as much as you can find us in the world of COVID right now, come and find us and talk to us and give us feedback, because it's the only thing that really drives us. And if you leave with anything today, just please remember that is just message us, get on our forums. Andrew's great at when he wants something, right, he pipes right up, and we can't ignore him, right? And so you need to do that, is make sure to get a hold of us. I can't say it enough.
It's a great way to close out the podcast. So make sure to follow Ehsan and Scott so you can bombard them with all your complaints about your Rhino, Grasshopper, or Rhino Inside problems, and PyRevit. Just
Yep. PyRevit has its own forum too, by the way, just like sort of like its discourse forum. So that's also a great place to ask questions and officially file complaints.
or just send them a message saying what a great job they're doing to bring them to offset the complaints. But no, thank you guys so much for joining. I think we'll close it out there. I don't know if there's anything you want to drop, or anything on the horizon for Rhino Inside you guys would like to promote, or PyRevit or anything like that. Feel free to do so. Otherwise, yeah, thank you guys so much for joining. I think, yeah, this has been one of our busier talks this year. So thank you so much. Make sure to everyone to give Ehsan and Scott a follow, and you can kind of keep up to date with what's going on in Rhino Inside. We will also be announcing very shortly that we've got our own Grasshopper introduction course that we will be releasing later on in March. We'll be doing a completely free and open Grasshopper 101 and Grasshopper 102 weekend where we'll be taking people through the basis of Grasshopper. And this is going to be the first in our kind of series of courses that we'll be doing on the Archi-Tech Network. That's always been a big goal for what we're trying to do, is to create courses and stuff to help close the gap between university and practice. So we'll keep you posted on that. Otherwise, yeah, thanks once again, Ehsan and Scott, and thanks everyone for joining.
Of course, thank you.
Thank you. It was great. So hope to hear from everybody soon.
Awesome. All right. Have a great Sunday, everyone, and thanks again for joining.
Thanks.
Thanks, everyone. Bye.
Bye bye.
Thank you, everyone.